Hi, welcome to my video on the conditions of continuity. This is video number 1. Conditions of continuity at x equals c for the f of x. And one condition is that the f of c, which is the constant, is defined or exists. The second condition, the limit of the f of x as x approaches c from the right side, positive, equals the limit of f of x as x approaches c from the left side, which is negative, is both of them are equal to n. That means that the limit as f approaches, the limit as x approaches c on the function f of x is equal to n. So the right side equal to left side, so the limit exists and the limit is n. And the third condition is the limit of the f of x as x approaches c is equal to the f of c. So wherever the value is, if it defined or exists, whatever that value is here, is also equal to this value here. The two of them are equal. So let's go through some examples to explain that. Number 1, I have a graph drawn. It says find each the f of 1. When x is 1, the f of 1 is a 3. Remember, f of x, the f of x is your y value. So what's the limit of the f of x as x approaches 1 on the left side? So as x approaches 1 on the left side, the limit, as you move over here, you're moving up this line, you will get a 3. And what's the limit as you approach 1 on the right side of the f of x, and you approach 1 on the right side? As you come in this way towards 1, you're coming along here, and you'll get a 3. So let's use this information to see if it's continuous at f of x. If f of x is continuous at x equals 1. So A, the f of c, so the f of c is 1. So the f of 1 is 3. So that means it's defined, it exists. So it's because the f of 1 equals 3, so it's defined, or we say the limit exists. Okay, B. So what's the limit of the f of x as x approaches 1 on the right side? So the limit as it approaches 1 on the right side is 3. And what's the limit of f of x as x approaches 1 on the left side? Approaches 1 on the left side, the limit is 3. So note the limit of f of x as x approaches 1 on the right side is equal to the limit of f of x as x approaches 1 on the left side. They're both equal to 3, so they're equal to each other. And hence, that means the limit of f of x as x approaches 1 is equal to 3. So that's the first condition is true, it's defined. Second condition, the left side and the right side are equal, same limit. And the C is that the limit of f of x as x approaches 1 is equal to the f of 1, which is equal to 3. So the limit as x approaches 1 is equal to the f of 1. They're all equal to 3. So that means that because the three conditions are true, that means f of x is continuous at x equals 1. So there's one example, and just to make sure that you understand, let's do another example, because there's nothing like doing more examples to make sure you understand. Number 2, we have f of x, and we have a piecewise function. So if x is greater than or equal to 2, we have x plus 1. If we have x is less than 2, we have x squared minus 1. Notice x plus 1 is a line, which has a slope of 1 and a y-intercept of 1. And this is a parabola whose vertex is 0, -1, and is opening upward. So let's graph the f of x. Before we do, is the f of x continuous at 2? So let's look at the graph. So we look at the graph of x is equal to, so if I look at x and f of x, or x and y, so x is greater than or equal to 2, x is 2, and a 3, and a 4, etc. So when x is 2, 2 plus 1 is 3. When x is 3, 3 plus 1 is 4. When x is 4, 4 plus 1 is 5. So it starts off at 2, 3. So when x is 2, y is 3. So that point is included. This is solid. And 3 gives you a 4. And 4 gives you a 5. So it's a line, but it's a part of the line. So actually it's a ray starting at the point 2, 3. Now we have a parabola and a parabola. So let's look at the parabola. Now let's look at the parabola right here. So we have the f of x equals x squared minus 1. We said the vertex of the parabola, x is 0, y is -1, and it opens upward. So the vertex is x is 0, y is -1. There's the vertex right there, and it opens upward. So if we do a quick table of values on that, we're only allowed to start at 2, so we got a 2, a 1, a 0, a -1, etc. And so the f of x, or the y, so if we put a 2 in here, x is 2, you get 4 minus 1 is 3. If you take a 1 and put it here, 1 squared is 1, 1 minus 1 is 0. Put a 0 here, 0 squared is 0, and you get a -1. And you put a -1 here, -1 squared is 1, 1 minus 1 is a 0. So this is a parabola, and again, this point is here. We got 1 gives us a 0. We have 0 gives us -1 vertex, -1 gives us a 0 there. So this parabola is doing this. There it is. Okay, we have the parabola. Now, so looking at the parabola, so we can see that this point is on the line, but it's not on the parabola, but is included in the function. So it looks like it's continuous, but let's explain using conditions. A, the f of c is defined, so the f of, we want to see if it's continuous at 2, so the f of 2, 2 is here, 2 gives us, put a 2 in, we have a 3. So it's defined. In other words, the limit exists because the f of 2 equals 3. B, so now we do the limit of the f of x as x approaches, we're approaching 2. So let's approach 2 on the right side. So notice the right side is greater than equal to 2, greater than 2. So this is the right side. So we have the limit as right here. So we're coming in on the right side. So that gives us a 3. Okay. And what about the limit of f of x as x approaches 2 on the left side? So we're approaching 2 on this side. We're coming in here. So what do we get? We have a 3. So that means the limit of the f of x as x approaches 2 from the positive side is equal to the limit of the f of x as x approaches 2 from the left side is equal to 3. And again, the first function I did is 3, but just a coincidence. I didn't really pay attention to the values in the first one being all 3s and here being all 3s, just a coincidence. So the limit, so that means the limit of the f of x as x approaches 2, the limit is 3. Now, we want to make sure, we got to make sure that where it's defined at and what the limit is the same. So the limit of the f of x as x approaches 2 is equal to the f of 2. Both of them are 3's, so it's true. So it's defined at 2. The limit to the right and the limit to the left are both the same, equal to 3, so the limit exists at 2. And where it's defined at 2, we get a 3. And where the limit exists at 2, we get a 3. So that means the f of x is continuous at x equals 2. So a couple examples down, just to make sure you know the conditions of continuity. And that brings us to the end of this first video on continuity. If you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that I have on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.